Okay, here we go. Today we are doing 6-1 and 2. Yesterday we did exponent review. Today we're going to be talking about radicals and simplifying radicals. Okay? When a negative is under an even root, this means the number is in the imaginary number system. And we talked about that. What do I mean by that? I mean if I have an example of being, let's say, the square root of negative 16. We know the square root of negative 16. When we did this, we said this was negative 1 times 16, which was going to be I squared times 16, which came out to be 4I. Do you remember us doing that? Okay, we did it just like that. So when we have a negative underneath of the even root, then you are going to have an imaginary answer. Okay? Index. Index is the number inside the root part of the symbol. It's the check mark concept. Then we have a radical. This is the part of the check mark. And then lastly, we have the radicand. So let me make sure that you guys are understanding this. The index is the number inside the check mark, and the little part there. That's the index. Then you're going to have the radicand, which is completely underneath the check mark. And then the check mark symbol itself is the actual radical. Okay, so these are all examples of radicals. This right here is understood to be the square root. And I want this. Come on, where's it at? Here it is. This right here is understood to be a 2. It is not necessary to be there. It is the square root, and the square root is, you don't see anything there, it's understood to be a 2. It does not have to be there. It's kind of like having 1x. You don't have to have the 1. You don't have to have the 2 there. Do we all understand that? Okay? This right here is the cube root of 24x. The root is the square root, is the radical symbol. The index is 3, and then the radicand is 24x. The index here is what on the last one? The 5. Then what is the radicand? 15x squared. Do we all understand those 3 words that I talked about? Radicand, index, and radical. Okay. Now, let's actually do some of these problems. The cube root. The cube root is what number multiplied by itself 3 times is equal to 8. What number multiplied by itself 3 times is equal to 8. Now, what I want your brain to do is say 1 times 1 times 1 is 1 cubed, which is 1. Yes? All right. Then I want you to say 2 times 2 times 2 is going to be 2 cubed, which is going to be 8. So what number multiplied by itself 3 times is 8? 2 cubed, which means the power and the root cancel out to just give you 2. The power and the index or root, aka index is root, aka index is root. Y'all with me? No. The index is also known as a root. So if I use the name root, I want you to be thinking index, okay? Now, this is the cube root of negative 8. What number multiplied by itself 3 times is negative 8? Okay, well that is going to be negative 2 times negative 2 times negative 2. This gives me 4, and this gives me negative 8. So negative 2 multiplied by itself 3 times is negative 8. So this is going to be the cube root, parenthesis, negative 2 cubed. Do you see my power of 3 on the inside and then radical, and as the radicand is divisible by my index or root, they cancel each other out to give you negative 2. Okay? Okay, the square root of negative 16. The square root of negative 16, we already know that that's negative 1 times 16, which we know negative 1 is I squared, which is going to be 4I. So what this means is it is not real. It is not real. Why is it not real? Because can I take the square root of a negative number? No, because there's no way to obtain a negative number unless the signs are opposite. Having $4 and owing $4 is very different. Positive 4 times negative 4 is the only way to obtain a negative 16, right? So that's why it is not real. Do we all understand that? Okay? Now, this one right here, the power of 2 that means the power and the root are going to cancel each other out again. So this becomes an x. Now, I have a problem with this. X is a variable. When x is a variable, I technically do not know if x is positive or if x is negative. Can I take the square root of a negative number? No, we just talked about that, right? So what this means is I have to ensure that this stays positive by putting absolute value bars around the x, because I cannot take the square root of a negative number. So what I'm saying is it can equal x as long as we take the absolute value of it. So what does this mean for us? When you are taking the even root of a variable and the outcome has an odd power, you must use absolute value bars to ensure the value remains positive. So you're going to hear me say this over and over and over again. Even root, odd power. Even root, odd power. Say it with me. Even root, odd power. Even root, odd power. Like, I need this in your brain. If my root is an odd power, an odd root, I don't care. I only care if it's an even root with an odd power on it. Okay? So here we go. Now, example. I am taking the square root of 64 and the square root of x to the fourth. Okay? One number multiplied by itself is 64. This comes out as an 8. And then you're going to take this power and divide it by this index. So 4 divided by 2 is 8x squared. Do we see that? I took my power of 4 and I divided it by my index of 2. Took my power of 4 and divided it by my index of 2. So that gives me an 8x squared. Now, do I have an even root? Yes, but do I have an odd power? No, so I do not need absolute value bars. Do we all understand that? Over here, square root of 169. Anybody know what that is?
13.
It is 13. Then I'm going to have 13, my power of 10 divided by my root of 2. So that's going to give you 13y to the fifth. Now here's my question. Do I have an even root with an outcome that has an odd power? Yes, I do. So I'm going to put absolute value bars around just the variable of the y. Tara.
Is the index always going to be 2 if there's not already one there?
If you don't see a number, then the index is 2. Correct. Okay? If you do not see a number, then the index is 2. Okay? Ready to do it again? All right. Now, I'm going to take my power, 30, and divide it by my index of 2. What is 30 divided by 2? It is 15. I had an even root, and 15 is odd, so therefore, I'm going to require absolute value bars. Does that make sense? Are we good? Yes? Okay, next. My variable is x. My power is 6. My index, it's not 2 this time, it is 3. So what is 6 divided by 3? 2. So now, did I take an even root? I did not take an even root, so therefore I don't even have to finish the saying. I'm done. I need no absolute value bars. Does that make sense? Keep going. Square root of 16. 4, so this is going to be 4, and then I'm going to take my power of 8 and divide it by my index. What's my index? 2. So what is 8 divided by 2? 4x to the fourth. Do I need absolute value bars?
No.
When do I need absolute value bars? Even root, which I took an even root, but I have an odd, I don't have an odd power, I have an even power. So therefore I know I am just fine just like this. Does that make sense? Okay, next. My A has a power of 6 with a root of 3. My B has a power of 9 with a root of 3. What is 6 divided by 3? What is 9 divided by 3? Do I need to take absolute value? Did I take an even root? Even root? I did not take an even root. My root is my 3. The index is 3. So therefore, I am just fine leaving it as this. Do we all understand that? Yes? No? Okay, one more time. My power is 6 divided by my index of 3. Since my index of 3 is odd, I don't need to have absolute value bars. Okay? My index over here is even, so now I have to come down here and check my power. My power is even, so therefore I don't need absolute value bars. Does that make sense?
So if that was odd, you would.
If it was an odd power, I would require absolute value bars. Okay? Keep going. Okay? X, my power is 8, my index is 4. Y, my power is 12, my index is 4. What is 8 divided by 4? So x squared and y to the third. Did I take an even root? Yes. Now, I have two variables. This right here is x squared. Do I need absolute values around the x squared? No. Do I need absolute values around the y cubed? Yes, which means I only have to ensure that the y is positive. The x will always be positive because whenever I square anything, it's always positive. Do we understand that? One more time. When I square something, a negative times a negative is a positive times a positive is a positive. So the x, since it's squared, will always be positive. But this y, it could be negative. And I can't take an even root and have an odd power, which is why I have to put absolute value bars around just the y.
So
Okay?
if the root's even and the power's odd, you put it down.
You put the absolute value bars. Even root, odd power, even root, odd power, even root, odd power. Okay? Okay, let's keep going. This is the cube root of negative 27. Now, a cube root, we did the cube root of negative 8, remember? What number multiplied by itself 3 times is negative 27? Well, we know it's not 2. So negative 3 times negative 3 times negative 3. This gives me 9 times negative 3 gives me negative 27. Do we see that? So that means this comes out as a negative 3 as my answer. Yes?
So why is it negative 3?
Because negative times a negative times a negative is a negative. I wrote down negative 3 times here. Do you see this?
Yeah.
3 times. When I multiplied the first two together, it gave me a positive 9. When I multiplied that by a negative 3 again, it gave me the negative 27.
So
Do you see it?
when you say that 3 numbers like times itself to equal 27, you're meaning like
Negative 3 times negative 3 times negative 3. You're multiplying that same number by itself 3 times. Okay? All right, now, what number multiplied by itself 4 times is negative 81? Okay, well, think about this. If I have an odd number of negatives, my outcome is negative. What if I have an even number of negatives? It's going to be positive. Can I ever get a negative multiplying the same number together? No. You know what this means? It's not possible, so therefore it's not real. This is whenever you'd actually have to do imaginary numbers, okay? I can't take an even root of a negative number. Remember we said that earlier. Now what is the square root? This is negative 7. My power is 2 and my root is 2. What is 2 divided by 2? What's 2 divided by 2? 1. So therefore, negative 7 is my answer. Okay? Okay? Okay, next. Okay, now, I have two radicals together. We're going to marry them. We're going to marry them. Sorry? Oh, I didn't see it over here. I didn't see it. You are right. I have this over here. Square root of negative 49. Can I take the square root of negative 49? Can I take the square root of a negative number?
No.
No, so what's my answer?
You gotta do it or if you want.
Not real. Can't do it. It's the imaginary number system, remember? Negative 1 times 49. Negative 1 is I squared. Okay? All right, number 8. Page 8. Is the last one for you? Okay. Now this one looks a little yucky, doesn't it? Now I have two of them put together. Now we're going to marry them and write them as 1. And the reason why we're going to write them as 1 is because they have the same index. Do we see that? So, what is 45? Off the top of your head, what can you think 45 is? Two numbers multiplied together give you 45. 5 and 9. I like it. How about two numbers multiplied together give you 35? 7 and 5. Okay? Now, how many total x's are over here in the first one? 5. How many total x's are over here? 1, so that gives me a grand total of 6. How many y's are over here? And how many y's are over there? To give you a total of? Okay. Now, do you remember, in order to take the square root, you have to have a pair of something, right?
Yeah.
What is the square root of 9? 3. Do I have a pair of 5s in there? Yes, so that can come out as 1 5, right? So I'm going to have 15. Then this x is going to be 6 over 2. Because the 6 is divisible by my root of 2, I can do that, right? That's what we've been doing the whole time. Would you agree with me? So what I have left inside there is going to be a 7y to the 7th. Okay? Now we're not done. 6 divided by 2 is 3. Now, is my power of 7 divisible by my root of 2? Is 7 divisible by 2? No. So what we're going to do is we're going to take 1 off of it and make that 7x, 7y to the 6 times y to the first. Do I still have 7 of them inside there?
No.
I sure do, but I'm just making it easier for me to look at, right? Which means now I'm going to rewrite this as 15x cubed y to the 6 over 2, square root of 7y. What is 6 over 2? 3. And that's done. Now, here's what I'm going to ask you. Would I need absolute value bars? Did I take an even root? I did. Do I have any odd powers?
Yes.
I do. I do have them on my x and my y. So I'm going to have to put absolute value bars around my x and my y. That is tonight's notes. It's harder today, isn't it? So we're going to go ahead and I'm going to start your homework with you. Tonight's homework is 612, worksheet 1. Are we ready? Ready to go? Okay, the directions say simplify each radical expression. Use absolute value bar symbols when needed. Absolute value bars are needed when you take the even roots and have an odd power. Yes? I put it right in the directions for you. So number 1, what do? What is the square root of 81?
9.
This comes out as a 9. So then I'm going to have 9x, the power is 4, the root is 2. What is 4 divided by 2? So this is 9x squared. Do I need absolute value bars? No, because I have an even power. Do we all understand that one? We good? Okay, let's keep going. Number 5. What number multiplied by itself 5 times is 243? So let's do the 2's first. 2 times 2 times 2 times 2 times 2. 3 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So that means 2 to the 5th equals 32. Not what we were looking for, was it? Okay, so let's do 3. 3 times 3 is 9. 3 times 3 is 9 times 9 is 81 times 3 is, well, 3 times 1 is 3. 3 times 8 is 243. So 3 to the 5th is 243. Is that what I was looking for?
Yeah.
Yes. Do we see that?
Yeah.
Now your calculator will do that for you too. Yes? So this comes out as a 3. Now I want you to look at your powers. Are your powers divisible by your index? Yes. So we're going to write that the way we like it. 3x to the 5 divided by 5. Y to the 15 divided by 5. What is 5 divided by 5? 1. What is 15 divided by 5? 3. Do I need absolute value bars?
No.
Why do I not need absolute value bars?
The index is
My index is 5, which is odd, so therefore I don't require absolute value bars, and that is done. Make sense? Okay, I'm still going. You ready? Number 7. Now I want you to look at this as 2 different bases. 25 is a base, and then x plus 2 is a base. Do we all understand that? Okay? So what is the square root of 25? This comes out as a 5. Then I'm going to take my base of x plus 2, and I'm going to take the power of 4 divided by my index of 2. Yes? What is 4 divided by 2?
2.
And there it's done.
Do you remember 8?
Probably. Let me see if it's on here already. Maybe we'll come back. We'll see. Okay, number 10. Okay, what do I have going on here? I have a fraction, don't I?
Yeah.
So what we're going to do is we're going to simply rewrite this as the 4th root of x to the 4th. Hi, honey. How long are you here?
Huh?
How long is she here?
I'm leaving in 3 minutes.
Bye,
That's
baby
my
girl.
thinking. Goodbye, Kendra.
Bye. Beautiful. Okay, we're going to rewrite this as the square root of x to the 4th, the 4th root of x to the 4th, over the 4th root of 81. Yes?
That just makes it confusing.
Do you think?
Yeah, for me.
Okay, so you guys are going to do them individually? Okay, if you want to do it individually, that's fine. We can do that. But I need you to understand that there are 2 problems in there, yes? Okay, so this top one's going to be the power divided by the root. Now, the 4th root of 81. Listen very closely. I'm going to rewrite this like this. What is 4 divided by 4?
1.
So that's x to the 1st. Now, what is the square root of 81?
1.
What's the square root of 9?
3.
Did you see we just found the 4th root? One more time. The square root of 81 is 9. The square root of 9 is
3.
3. So, do I need absolute value bars?
Yes. Yes.
Why? I had an even root with an odd power, so I have to have absolute value bars. Does everybody understand that? Okay. Now, number 14. The directions say, simplify each radical expression. Assume all variables are positive, meaning absolute value bars are not needed if you have an even root and odd power. That should be a not. There should be a not in there, y'all. Are not needed if you have an even root odd power. So we are assuming that everything's positive always. You with me? Okay, so here we go. We're going to marry these together. 3 times 27. Can anybody tell me what 3 times 27 is? It is 81. So what is the square root of 81?
9.
It is 9. Okay, number 17. The fourth root of 256. Anytime you want to use your calculator for that, you can. I'm not going to tell you you can't. So you can go ahead and say the fourth root of 256 and hit enter. That gives you 4. So this comes out as a 4. Now, this is where things are going to get ugly. Why are things going to get ugly here? This power is not divisible by that index, is it? So we're going to make it divisible by it. So that's going to be s to the 6th, which that doesn't work either, does it? It's going to be s to the 4th. Then how many s's are left?
There's 3.
3 more. Is 12 divisible by 4?
Yes.
Yes, so you're going to leave it. So that's going to be s to the 4 over 4, and then 12 over 4 is equal to the 4th root. No. The 4th root of s cubed. 4 divided by 4 is 1. 12 divided by 4 is 3. And you do not need absolute value bars because it said to assume that everything was positive, yes?
Hey, will you check my email?
Eventually.
Thank you. It's about the National Honor Society.
Okay, do we all understand this?
So we don't need absolute.
You do not need absolute values because the directions on this page said to assume that everything was positive, right? Okay, you guys are going to struggle with these last two, but I'm going to let you guys clean up because we're out of time. Deal?
Are we doing this for